Hey, for any time. All right, so I'm gonna work this 3-box problem that people had trouble with on the quiz. So you assume they're equal densities, and so it's the least massive, and it gets more massive as you go down. So you start off with A, the simplest one. You want to keep it. My suggestion is keep it small because it's going to get out of hand. The normal force going up is going to get out of hand after a while. So we'll start off with A and make it kind of short. Let's go down. Alright, not that far, and that's MAG, and I noticed what students are doing is they're just calling it MG, but if you have more than one object involved in a problem, you're going to have to distinguish whenever you do the MAG or MBG or MCG, okay, you have to, and it comes after the M, not the G. So there's a normal force on that, and the normal force is going to go straight up. This not quite colored, so. And it'll be equal distance to what the MG is. So it's supposed to be anyway. So 40, yeah, it's about the same. So these two are congruent. All right. Now, the source of this is the box B below. So whenever you do a normal force, I use a subscript to tell the source. So normal from box B. Okay. Now on box B, that's the middle box, and so it's going to have two forces down. It's going to have its weight. So that's I'll just make these double every time. And then it also is going to have the normal force from A. Okay, so it's supposed to be double. Alright. Oh, I see. Oops. A little further. Okay, there we go. So there's for box B, two forces down. So I have this is the actual from Earth. The effect that Earth has on B, so it's in BG, and this is the normal from box A above, or sometimes called the overburden. And the overburden on B then is the normal, and the source of that is A. Now, some of you said, or some of you have been saying that's MAG. I agree, that is congruent. It's the same length, but you don't want to call it that because when I say MAG, I'm thinking the source is the Earth. But really the source of this is not the Earth. The source, as far as box B is concerned, it has an overburden. It doesn't know what the source is. So all it feels is box A. So you have to be very logistic about this. And now I'm going to go through and add these up. The two bottom down forces have to equal the up force. It's in static equilibrium. And so I'm going to have 40 plus, so I'm going to have 30 up. So I'm going to go up to this. This is already getting out of hand. So that's going to be the normal. Now that's the normal, and the source of that is box C. This is the box below B. Okay? So now we go to box C, and now C has got two boxes on top, and a lot of you want to put three forces down, but you don't. It's only box C does not. Box C has no idea that box A is up there. It just thinks that box B is heavier than it really is. Okay, so on box C we're only going to have two forces down again, and I'll make it a little bit bigger again. Going down to 40. We're not out of room, so I'll go down to 40. Let's see, 60 to 30. Okay, so this guy. Okay. So there is MCG, okay, it's its weight. And then there's the normal force. Now the normal force, I'm going to run out of problem. I'm having a problem here. Because the normal force now is the combination of these two forces down. So that's basically this guy set down here. So 50 to 80, so that's 30. Really?
Yeah, Jimmy. We put OSSN. We don't want an OSSN.
It's coincidence, I guess.
I don't understand why OSSN doesn't do block loss.
So it looks like that's the normal force, and coincidentally it happens to be, and that's the normal, that's going to be the normal from box B above. So that's the normal from B, this area right there. And then you add these, and then of course you got to add these up, and now I'm probably going to go off my graph, but we got, so we're going to go, I think I'll get on there. 40 up to just about, almost get on there. This guy's going to go way up. Now the normal here, the source of this normal force is the table. So I say N sub T for table. Okay? So there's all, and those are the only three that are congruent. I guess that one ends up being, let's see, congruent to, yeah, because that's a combination of these two. So I guess I could put a congruent symbol there and a congruent symbol there. That'll work. And that's just a coincidence that I happen to make. I could have made C longer. Because, I mean, it just happens to be congruent there. That's not close to congruent. It's a little longer. Okay, so that's how you work. And this is the simplest of the 3-box stack. It's not an easy situation, but this is the simplest because then what you can do is you can make the whole thing move and then accelerate, and then then you got static forces in between. You can put the thing on an inclined plane. There's a lot of things you can do with it, but for now, we're good. Think about that. Your links are important, and make sure your labeling is correct. In case you see us on the next quiz. Okay, so we got